Hello, welcome back. My name is Ethan from ethansarduinolessons.com. Today I'm going to show you how to make a dynamic display using an Arduino. An LCD screen coupled with an accelerometer can be used to measure the number of steps being taken by a person or by a thing by keeping a count that increases when motion is detected, such as a step, and displaying that step count on the LCD. This idea can be further improved to specifically track the vibration of the accelerometer attached to whatever you're measuring. It can be used to track motion in a specific direction, track whether or not it's being rotated. There's a wide range of potential uses for this. So let's hit it. Here is the circuit, here's the schematic for it, and here is the Arduino code to go with it all. With this, we can make the LCD say what we want. Wow. We can make it say hello world, hello earth, hello globe. There's endless possibilities here, but it's not very dynamic. It's not tracking any changes. So let's add a tilt ball sensor, like so, attached between digital pin 2 and ground. Now if we tap anywhere near the tilt ball sensor, the count increases, as this is enough movement for the sensor to pick up. This same code can be used to measure my steps, as one step moves the tilt ball sensor enough to count as one step or close to one step. You can see it's not perfect, as 8 steps counted as 9, but it's close. A delay was added in the code that works for my stride, for my gait, and this delay will ensure that one step doesn't count as 2 steps, and that one step stays one step. But even this could be made better. Using an IMU, we can track either linear movement on a certain axis or gyroscopic movement. Here's the code used, which keeps track of 6 things: acceleration on the X, Y, and Z axes, and gyroscopic movement along the X, Y, and Z axes. I received data from the serial plotter for 20 seconds of walking, I exported it as a CSV, and I analyzed the data using this hefty MATLAB code, and I found that the plot for my acceleration along the Y-axis was fairly uniform, and that the values never went before 3 meters per second squared. So, this specific data will be used to count my steps. Now, if I walk, while honestly exaggerating my movement, it'll count my steps even more accurately now than when I was using the tilt ball sensor. This same idea can be shrunk down, so you don't have to hold this big circuit, and used for a variety of uses, including monitoring the vibration of car parts, tracking when a door is opened or closed, or tracking movement when placed in an iPhone or tablet. Wow, isn't that pretty cool? There's a lot of cool things you can do with an IMU. If you liked that, like it. Thanks.